Hello, and thank you for joining our session today. My name is Eric Trower, and I'm a member of the marketing team at SICK. For those of you not familiar with us, SICK is a leading provider of sensor solutions. Today, we welcome John Callum, Market Product Manager, along with guest TJ Albright, Business Initiative Leader of Refineries, and Dylan Mejias, Business Initiative Leader Chemical, who will discuss how a multi-component system can reliably reduce response times, allow for a quick feed-forward control, and help you meet EPA NOx regulations. If you have any questions during the presentation, please type them in the Q&A box found on the right-hand side of your screen, and we'll take time at the end of the presentation to address as many questions as time allows. Lastly, I'd like to mention that following today's presentation, a recording of this webinar will be emailed to each of you, as well as those who registered but were unable to attend. So at this time, I'd like to turn it over to our presenter, John Callum.
Good morning. Thank you, Eric, for the introduction. Today, we'll be discussing analytical measurements to help meet the EPA NOx regulations. I would like to give you a quick, for those that are not familiar with ZIC, a little more overview of our capabilities and our footprint. Erwin Zick founded the company more than 74 years ago. It's a privately held, family-owned company. Grown from just a garage operation to 11,000 employees worldwide. So a great success story, global coverage, and over $2 billion in sales globally. We have, as Eric mentioned, we got a really wide product and technology range. Lots of sensors. You may have heard of us for analyzers or for flow meters, but we have over 40,000 products that we produce. And one of the great things about working for ZIC is they put a lot of money back into R&D. So we reinvest, 10% of our annual revenue back into new innovations and new products. So if we go from left to right, one of our divisions, our global business centers, is responsible for presence detection. So what does that mean? We have lasers, high precision lasers that'll measure from micron to mile. So very precise measurements, proximity measurements. And then one of the very first products that was developed by Erwin Zick was the industrial safety light curtains. So you may have seen those in factory automation. Protects the light curtain that protects employees from machinery, from injuries. We'll do the complete safety audit for you and do a turnkey system. The analyzers, the group that I'm working with, I'm the market product manager for. We have both compliance, analyzers as well as process analysis solutions. And then the flow measurement, we have a very robust offering for ultrasonic flow measurement. One of the leaders of custody transfer measurements for natural gas. And also a very robust flare flow metering, which flare flow is a very challenging application. We do that quite well known for that. Then we have app space and industrial integration so that customers as well as us can take our products and then custom divide, come up with custom applications and designs. We also have a systems integration group where we can take third-party products as well as our own, integrate them into complete solutions. And then motion control, we have rotary, linear encoders, contacting and non-contacting. And for trace and track, we have identification and measuring RFIDs and 2D cameras for that business. And then we have a cool new business development, it's an incubator. So if you come up with a good idea, develop a business plan, the company will, once it's approved by the board, will provide seed money. So that allows us to have our own incubator system to look at new technologies and develop new products for the marketplace or emerging markets. We have 3 different divisions: factory automation, logistics automation, and process automation. We have great, we're a trusted partner and have great brand recognition in factory automation, logistics automation, even in process automation for the oil and gas group. Today, we're predominantly going to be concentrating on process automation and the industries that process automation group serves, which are, cement, chemical, petrochemical, refining, maritime, metal and steel, mining, oil and gas, power, and waste and recycling. So to get into our analyzer portfolio, we have both in situ and extractive. And in situ just means the analysis is taking place in the process or in the stack. Extractive means there's a sample system that's conditioning the sample and bringing it to the analyzer for analysis. The key analyzers we'll discuss today will be the GM32 and the GM700, TDLS, and the D4. Just to show you, we have a broad offering for certainly O2 for combustion control. And then we have a Merchem for mercury, a variety of different other analyzers to meet your both your compliance and your process measurement solutions. But today we wanted to talk about NOx. So what is NOx? Nitrogen oxide or oxides of nitrogen. Comes in many forms and it's created during the burning process or combustion. And then we're also going to talk about the DeNOx process and some of the removal methods for NOx. So the formation of NO or nitrogen oxide, there's fuel NO, which is bonded in the actual fuels themselves. So whether it be coal, wood, waste, oil, diesel, whatever the fuel type is, it has a resident NO component within it. And then also thermal NO. So at high temperatures, NO can be created. And then there's a prompt NO that can come about when you have incomplete combustion or fuel-rich combustion. And then this lists out the different contents of the thermal, fuel, and prompt NOx for the different fuels. So why would we measure NOx? Of course, the EPA has guidelines, and we have to do that to be in compliance. But the main reason is that there are harmful effects from nitrous oxides. It's toxic to humans and animals. It can cause smog and acid rain and contribute to ground level ozone. And a lot of the thermal power stations, power plants create and account for quite a bit, but there are multiple sources. Automobiles and any combustion process can produce NOx. So there are several removal strategies. The ones that we're really going to focus on today is the SCR, selective catalytic reduction, and the SNCR, the selective non-catalytic reduction. But there are other ways to remove or mitigate NOx, which is low NOx boilers, increasing the combustion efficiency to make sure that you're not in a fuel-rich situation. So there's multiple ways to mitigate the NOx, but whatever strategy that you use, you still have to measure the effectiveness of that and meet your permit requirements via the EPA guidelines or state guidelines. So to explain the two just briefly, the selective non-catalytic reduction is using direct ammonia injection to convert the NOx from NOx to water and nitrogen. The selective catalytic reduction is using not only ammonia injection, but a catalyst. So injecting the ammonia prior to the catalyst, reacting all the NOx that's in the stack, and then converting that to water into nitrogen. Dylan, TJ, anytime you guys feel you would like to add anything, please feel free to jump in. So the SNCR principle, the reduction to a removal of NOx, both are viable. We're not promoting either or, but depends on your specific application, what your loading is, your NOx levels, your fuel types. There's a lot of things that go into selecting the proper removal technology. But what we do very well is have the analyzers that will measure the ammonia and also the NOx in situ, which is a real fast measurement, and it allows you to optimize either the SNCR or the SCR to optimize it to make sure that you're not over-injecting ammonia. If you over-inject ammonia, there's some effects of reducing the cost or life of the costly catalyst. And also ammonia is not cheap, so you can reduce the amount of ammonia that's used as well. So there's some financial reasons why you want to go with a device that gives you tighter control, allows you to optimize your performance of the removal technology that's selected. So the SCR principle that we're moving, we are actually using that catalyst as well as the ammonia injection into it. And what we're doing is we're measuring that slip that comes through the ammonia slip. And what we call ammonia slip is you want enough ammonia in there to fully react and reduce or remove all of the NOx. So what you want to, the only way to measure that to make sure you're going to have enough in there is you have a little bit of residual on the downstream side that's going to break through. So we're measuring that really low level breakthrough, make sure that you have enough catalyst or enough ammonia along with the catalyst to effectively remove the NOx.
Yeah, and for this is Dylan. For that low slip, I mean, you're looking in probably, I would say, sub 5 ppm, really sub 2 ppm of ammonia for an optimized conversion. So you do need a device which is going to be very accurate on the low end. A lot of devices which are out there are good to the 0 to 25 ppm for ammonia, but when you look at that low measurement and low and high accuracy at that low measurement, you're going to be probably leaning more towards something of a TDLS, which I think John's going to be talking about here in a bit.
Yep, good point, Dylan. It's imperative to be able to measure those low levels, accurately and repeatable to provide the tightest, optimized performance of the SCR. Make sure that you're removing all the NOx, but make sure that you have enough. So it's kind of like the Goldilocks type thing. You don't want the porridge to be too cold, too hot. You want it to be just right. So this way you're able to optimize performance and reduce the amount of ammonia that's injected, and then make sure you don't over inject and create an issue where you're damaging your catalyst. So the SCR control ammonia slip, this is a way that we can, a picture's worth 1,000 words. So you got your high NOx that's coming in from your stack. It's going into the SCR, and then you're injecting your ammonia prior to your catalyst bed, and then it's reacting and it's converting the NOx to nitrogen and moisture, which are benign components that are naturally occurring in the environment. So that's the basic premise of how the SCR, NCR work. The DNOx and the SCR control shows you a typical install with our devices, where we could have the GM32 on the inlet measuring the actual NOx, and then giving a feed forward signal over to the ammonia injection, so they know what the loading is, what the NOx levels are, so you know how to adjust your ammonia feed so that you're not overfeeding. And then we can measure the with the GM700, the TDL that Dylan mentioned, the ammonia slip quite accurately as well. So you know what's slipping through, and make sure you have the proper amount of ammonia. And we can give you the feed forward to optimize the control. So we pretty much talked about that, or now about the benefits of having proper injection control. One was, if you have too much of, chemicals in there, you can provide corrosion. And we talked about the catalyst life, and some of these catalysts are very expensive, several $100,000. So you can extend the life of that. There's a definite ROI calculation on that to provide significant cost savings. And then, of course, the storage of ammonia and the actual product itself is not inexpensive as well. So if you can reduce the amount that you use, you're going to reduce the total operating costs of the removal technology. So we actually, I talked through that one already, so I'm going to cruise past that. So what are the different methods or topologies for measuring NOx? We're primarily today talking about the in situ because we're trying to optimize control, and this gives you the fastest response. It's in the stack. We're not conditioning the sample, and we're not extracting the sample, so we don't have any sample lag times on that. So from left to right, the in situ would be our preference for a control strategy for the SCR or SNCR removal strategy. But we also manufacture and supply hot wet solutions where we keep the sample above the dew point as we extract it and bring it to the analyzer. It's heated as a heated sample line, umbilical pump all the way through the analyzer. It stays hot above the dew point. So it's a robust system for applications that have high particulates and applications that are measuring acids that possibly would condense. But we can do the hot wet strategy, which is extractive, and also cold dry extractive as well. And a lot of the cold dry extractive we use on traditional SIMS measurements to measure NOx. All have their pros and cons. The cold dry has more components here because we're doing extraction, we're doing cooling and dropping out moisture, have a lot of filters. So there's a lot more components that are involved in that. And the best thing about the direct in situ measurement for controlling and optimizing is the speed of response, being in the process rather than having an extracted sample and dealing with maybe the sample delivery time, delay time. Dylan, anything you wanted to add to that?
No, nothing on this.
Okay. So one of the huge advantages for the in situ device is we have the capability to mechanically do our daily validations with zero reflectors and span filters to do your daily checks and verifications without calibration gas. And we all know that calibration gas, cylinder gas, is expensive to procure and to maintain. So you can think of how much it costs you for a cylinder of gas. And if you had to do that 365 days a year, maybe you're going through a cylinder per quarter, so that's 4 cylinders, or maybe you're going through one a month. You can do your own calculations in your head on how much money that would save you there. And also, we all know that analyzer is guilty until proven innocent. So if you have to challenge the analyzer, or if there's a challenge from operations and it's not working, you can physically hit it, maybe a digital signal, send it to the analyzer, and then you have positive indication of performance. So that's huge when you have a question about the analyzer operations, questions the reading. You can initiate this verification cycle for testing as well as to meet the daily verifications via the EPA. You still have to use your gas for your quarterly checks. So we can still introduce gas to the device, and you'll see that coming up a little later how that's accomplished. But we can do both live gas as well as to mechanically online without removing the analyzer via a mechanical device, filters and things. You'll see that just in a minute. But the nice thing is the speed of response. We're not conditioning or changing the sample, and there's no sample system on it. And the maintenance and the install cost is typically lower than an extractive system. So the GM32, which we would use as an in situ device and analyzer it can measure up to 4 components simultaneously. So it can do NO2, ammonia measurement, as well as moisture. This is the single probe design. So it's single penetration into the stack. It's hard to see here in this particular photo. This is your optical path, and it has a gas permeable probe on there, so it allows you to flood the optical path with gas for your quarterly validation verifications. So it uses a UV technology, so it's a UV lamp, and it can measure, as you said, the four gases plus pressure and temperature. And then, as we mentioned before, it can do the rotate in the fan filters and also the zero reflector to do your daily validations mechanically while the unit is functioning and online. And then there's an auto alignment correction as well to make sure all the optics are continuously aligned and peak performance. Dylan, did you want to add anything?
No. So the good thing about this is the GM32 actually comes in 3 different configurations. So John mentioned that. I mean, you see the probe right here. So this is the purged air probe. If you don't need to test it with, if you don't need to put it on test gas every now and then, you can go with this one because it's going to be an open path purged air probe. There is a filtered probe. Usually it's going to be a ceramic filter, just because very high temperature, the Teflon filter typically won't hold up. And as well as it does have a cross-duct application. Usually the installation is a lot easier for a single-sided insertion, but it does have a cross-duct application as well. So that's going to be what John's showing you here is the GPP.
And then jumping to the GM700, which is a TDL, tunable diode laser spectroscopy technology. We also have the same single probe design as well as cross duct for that product as well.
Yep, and so this is what I was talking about in regards to the accuracy of the measurement. So the GM700 is a TDLS, very accurate on the low end, usually about plus or minus 0.5 ppm or so. The GM32, so the GM700 is specifically only for ammonia. It's a single component analyzer only for ammonia. The GM32 is a multi-component analyzer. The analyzer can read SO2, can read NO, NO2, the summation being NOx, and can read ammonia. The range for the GM32 for ammonia, however, is typically around 0 to 25. And the GM32 has 2 different variants for the NOx measurement, really just depending on the application.
Okay, thanks, Dylan. Having some bandwidth issues here, so hold on a second. Okay, turned off the video. The bandwidth was being strained, so here we go. So as Dylan was talking about, this is the single probe design, and then this is a cross duct. So depending upon your application, your ranges, and also physical constraints of where you're mounting the device and where you have access, would determine which one of these you use. Both would work, but one may work better for you. You may have access on only one side of the device, as far as platforms, and it might be more beneficial to put the single probe in. Single probe usually is easier to put in because it's only got one little connection. But if the application dictates as far as the range, and we need to get a larger optical path, that might be one reason for going for the cross duct. But typically for both the GM700 and GM32, They are in situ measurements, so they do have a lower initial cost for installation and lower maintenance cost and lower cost of ownership and fast response because we're not modifying the samples in situ. It's very fast response time. Excuse me. And then we do have the different variants to cross-duct and the single probe. So in summary, we talked about the measurement solutions and we talked about the benefits of in situ. But if you do have an application where you need hot, wet, or cold dry, you have all three. We'll do an evaluation with you and your team and evaluate the information of your application, and we'll recommend the technique that's best for your application and allow you to make the educated decision on which route, which measurement topology that you'd like to use for your application to make sure that it meets or exceeds your expectations. So what we discussed today is, how NOx is formed, what it is, why we should care, why we should measure it, and then what are the removal methods. We concentrated on SCR and SNCR. We talked about the benefits of in situ measurements and optimizing the SCR control. We talked about ZIC has all three technologies: in situ, cold dry, hot wet extractive, and then we have experts, MAEs, and our engineering team that would be delighted to talk with you, with your team, either at your site and do site surveys or virtually, whatever is more feasible, so we could really look at your application, find out what your needs are, come up with solutions that we can present to you. And we'd love you to call in sick today. Call us in. We can work with your teams. Come up with a solution. It's going to meet your needs. So I thank you for your attention. And Eric, were there any questions that came in during the presentation?
Yeah, great. Thank you, John. And just for presenters, John, TJ, and Dylan, just feel free to pipe in for answering any of these. But yeah, for our audience, if you just take a look at the right-hand side of your screen, there's a Q&A section on the WebEx screen. So any questions you have, you can just enter those here for the team. And we do have a couple that have come in. So let me just start off with the first one here, which is, what is the accuracy for each component of the device being used?
Yeah, so I mean, I can answer that one. So the accuracy is going to be very application dependent. Usually it's going to be 2% or less is what we're going to shoot for. And when we look at when the application questionnaire gets filled out, we will actually go through and pick the proper length of the probe, proper measuring path, and everything to fit the needs of the application to meet that accuracy. For, like I had touched briefly earlier on the GM32, it has two different versions of measuring. So the GM32 has the UV principle. So it's the differential, it's the DOAS differential optical absorption. And then you'll also have, as well, same, but we use an LED light. So it's, and rather than the standard deuterium light, which we use for a low NOx version, so to make it more accurate on, for specifically this application for the outlet analyzer, we would probably use the low NOx version, which is going to be an LED. And that LED allows us to essentially get tighter on the lower end range. So that way, when because you're going for that conversion efficiency rate on your SCR or SNCR, and so you want to maintain the highest conversion efficiency rate. So the higher the accuracy is on the lower end, will be better for the GM32 using that LED light source. So typically we're going to shoot for around 2%. That's going to be our target for the accuracy for the components.
Okay, great. Yeah, thanks, Dylan. The other question that I have that came through here was, what is your typical maintenance for this type of in situ device?
John, I I guess I can answer that as well too.
Go for it.
So for the maintenance for the device, I mean, we all kind of know maintenance is different at every plant. And to say a device that is no maintenance, I would be lying to you. But the maintenance is minimal when you in comparison to an extractor system, whether it's hot, wet, or cold dry. So the maintenance for the GM32 is going to vary as well, depending on type of probe, whether it's a purged air probe or the filtered probe or a cross duct. The probe aspect is usually going to be a reflector and some lenses. The analyzer aspect, maintenance, is going to be, you'll have the beam splitter. It's just the nature of the beast when you use the deuterium lamp, that it will over time start to milk the glass. And so that beam splitter, usually we can just, it's probably gets exchanged out within 15 minutes or so. You just take off the cover and it's 2 screws and it slides out. As well as the lamp is going to be essentially the main maintenance of the analyzer. You do have some moisture bags within. You'll have a moisture charcoal bag within, as well as some silicone, essentially tablets almost, that are put into the analyzer to keep moisture out when you're into such areas as the Gulf Coast where we are, high humidity. So high humidity, high temperature, high moisture. So once you get into those, that's when you may exchange those out more often. But usually you're changing a beam splitter about every 8 months to a year, and a lamp about every 1.5 years or so. But this depends on quite a few things within the process as well. So
Sure.
that would give you a good baseline.
Yep, and Dylan started with Zick in the service group as a service engineer, so he can talk from a experienced level that I cannot. So I appreciate you answering that, Dylan. And one thing I might add as well is Zick is full service provider, and so we also offer preventative maintenance agreements. Whereby our authorized service personnel would come in and do either an annual or twice a year or quarterly, maintenance on the analyzer, so that you make sure it's always in optimal performing condition. But we offer those standard agreements as well. So have our service guys do the maintenance for you if maybe you don't have the personnel that you could dedicate to that, or you feel it's more cost effective to have our guys that are factory trained to do the maintenance. So that's an option as well.
Yep, and one of the other things which John had mentioned briefly in his beginning of introduction of SICK was what we call internally GBC05, which is our essentially integration group for connectivity. And so something that we're working on and building into the platform of the GM32. We have it in platforms of our other analyzers, but we're building it into the GM32. Is going to be condition monitoring. So that way, this will also help with some of the maintenance aspects, where you can understand more in depth of what the analyzer is doing and when you potentially need to do maintenance. So this condition monitoring will give you kind of a layout and give you that trigger to say, hey, my light source is getting a little dim. Let me go take a look at that and give you that flag. So it's something that it's already in progress, and we'll be releasing soon for the GM32 specifically.
Yep, thanks for mentioning that, Dylan. We did have a little blurb on that, but we didn't really highlight it. So as part of that condition monitoring and a thing we call SICK Connect, we can actually provide virtual assistance remotely as well, and we can take that information and put it into either a SICK cloud or customer cloud wirelessly, or to a server inside of your facility so that you have access to it. But eventually that tool will, right now we're grabbing that condition information, but the next step is to make that, as Dylan said, a predictive tool where it tells you, hey, I have a issue, or within 2 to 3 months, you need to change the lamp, or that way it's a smart device and it's constantly monitoring itself and it's telling you when it's in a condition when it needs maintenance, and specifically what needs to be monitored and what needs to be changed out at the proper time to give you a device that you can be sure of, that's making a reliable, accurate, and repeatable measurement, and it's keeping you in compliance.
All right, great. That being our final question, I guess we can wrap this up for today. But thanks again to John and Dylan for your presentation and for responding to those questions. As you can see, John has all of your information up here, the contact information of our presenters today. So please feel free to reach out to them if you do have anything that comes up following this presentation. Otherwise, stay tuned for upcoming webinars from our Live from the Insights Experts series, which can be found in our newsletter. Thanks again, everyone, and have a great day.
Thank you.